hydrogen to organic compounds. And so the reason why supercritical fluids are important in the context of hydrogenation is that hydrogen is not very soluble in ordinary liquids. So you can see here, if you've got hydrogen liquid, you have to stir really hard to get it to dissolve. But a supercritical fluid is a highly compressed gas, so it mixes completely with hydrogen. This slide is designed for young children. You see that blue plus yellow makes green, just to show you that it mixes really well. So the idea is that in hydrogen, in a supercritical fluid, for a given pressure, will give you a higher concentration of hydrogen. So all being well, your reaction should go better. And I believe that my student Steve Howdle and I were the first people to point out this high solubility of hydrogen. Anyway, together with Thomas Swan, we built some apparatus for supercritical hydrogenation. I don't know, do you have chemical engineering at your university? Well, in chemical engineering terms, this is not very sophisticated, but you have the reactant, what is going to react, and hydrogen, supercritical CO2 come in, and you mix them together. And originally, we literally had a little stirrer. Now we have a slightly more efficient method, and then it goes through a tube which contains a catalyst, reactant turns to product, and here you release the pressure, carbon dioxide goes one way, product goes the other. And here is my colleague Pete Licence, who's just been made. He was my postdoc when this photo was taken. He's now a professor. And the mixer is here, the reactor is here, and the product comes out the bottom. And the reactor, if you want to see for size, is about this size. This is a reactor, and you can have a look at it. Please give it back. I need it to give a lecture in Beijing next week. And so I was in Moscow giving a lecture about this, and I said that getting the product out is as easy as milking a cow. And suddenly there was a lot of whispering in the audience. And I stopped and asked them what were they asking. And they said, we're all discussing whether you've ever milked a cow. And I said, has anybody here ever milked a cow? No, dear. You see, it's a very urban environment. Apparently, it's quite hard to milk a cow. So it's easier to get the chemical out than milking a cow. And collaborating with Thomas Swan, we built a full-size chemical plant. You can see here's a worker standing by the reactor, and you can see the size of the lab reactor. And this went on stream in 11 years ago, and it was the first continuous multi-purpose reactor in supercritical fluids on 1,000 tons a year. And the reaction we did was to hydrogenate this molecule here, which is called isoferrone. You can make this from acetone. And to make this product here, which has the unromantic name TMCH, which is used as a solvent for various fragrances and things like that. And this is the very first bottle that was made. You can see it says batch 1. And you may not realize it, but chemists or academic chemists don't normally make chemicals on a large scale. So I was sitting in my office with this bottle, looking at it all morning. And then my students came and said they needed it, and I haven't seen it ever since. And so technically, it was a terrific success. But in terms of energy, your provost mentioned energy, the energy requirements for compressing the CO2 was really quite high. And so in the long term, it was too expensive to use to make this material.